and students. Today we are going to discuss about inductive effect. In this session, we are going to discuss its definition, corresponding examples, and different types of inductive effect groups. And we are going to do some questions also. And as a part of inductive effect, we are going to discuss about electronegativity also. So first we are going to discuss about the definition. So what is the definition? The displacement of sigma electrons towards more electronegative atom is called as inductive effect. So guys, inductive effect nothing but it is the displacement of sigma electrons towards more electronegative atom. For example, here you see X is more electronegative halogen. So what happened here? All the sigma electrons are displaced towards X, you see now. So this type of displacement of sigma electrons towards more electronegative element is called inductive effect. Now you see this example. You tell me, do inductive effect is operated in this one? No. Why? Why? Because there is no electronegativity difference. That means there is no electronegative atom bonded to the carbon atoms. So tell me, what is the reason for inductive effect then? Inductive effect arises due to the difference in electronegativity. Guys, very important point is this one in inductive effect. So what is the main reason for inductive effect? It is due to the electronegativity difference. Now we are going to see its important features. So what is the first one? It is a permanent effect. What is the meaning of this one? Now for example, I am taking one compound like this, and in this one, tell me which is more electronegative element? Yes, it is halogen, that is chlorine. Due to its high electronegativity, what happen? Electrons will displace towards chlorine. After displacing, again they will not come back. That is the reason why it is called permanent effect. Now, second one you see, it is due to the difference in electronegativity. As I stated just now, that inductive effect is due to the difference in electronegativity. Then next one you see here, it is transmitted through sigma bonds, correct na? Now you see here, it is transmitted through sigma bonds only. All the sigma bond electrons will move towards more electronegative halogen. Next, the most important point in inductive effect is it is distance dependent. How it is distance dependent, sir? Now here I am taking one compound in this way. You know well that X is halogen. So it will withdraw electrons from the carbons. Can you tell me it withdraw electrons easily from first carbon or second carbon or third carbon? Yes, it withdraw electrons easily from the first carbon. Then what happen? As the distance is increasing from X, its withdrawing tendency what happen? Decreases. That means inductive effect is inversely proportional to distance. Guys, these are some important features of the inductive effect. Now, as the part of inductive effect, there is a need to discuss about electronegativity, which is more important term in chemistry. Now, what is electronegativity? It is the tendency to attract bonded pair of electrons towards more itself is called as electronegativity. For example, let us think A and B are two atoms. In this way, a bond is formed between them. Let us consider electronegativity of A greater than B. Then what happened? Tell me. These bonded electrons will move towards A. Then as a result, A will get partial negative, B will get partial positive charges. So on the whole, what is electronegativity? It measures the negative charge holding capacity. See, here I mentioned, let us consider electronegativity of A greater than B. So, whose electronegativity is more, it should hold the negative charge. Such type of negative charge holding capacity is called as electronegativity. Then you can ask me, sir, electronegativity depends on what? Remember, in hybrid orbitals, electronegativity directly proportional to percentage of S character. Now here you see, no, if you take sp hybridization, S character is only 50%, whereas sp2 if you take, then S character is nearly 33.3%. Next, if you take sp3, it is 25%. So S character is more for sp than sp2 than sp3. That is the reason why electronegativity of sp carbon is more than sp2 carbon than sp3 carbon. Interesting, na? Now, in periodic table, the highest electronegative element is what? Fluorine. Then, second highest electronegative element is what? Oxygen. Then, third highest electronegative element is nitrogen. Guys, don't forget these three. These are the first three highest electronegative elements in the periodic table. Now, one question for you guys. Which is the more electronegative element in carbon and nitrogen? Obviously, answer is nitrogen only. No doubt in that one. But as I mentioned already, electronegativity also depends on state of hybridization. Now, for example, you take sp3 carbon and sp3 nitrogen. In that case, which is more electronegative? Nitrogen only. Or sp2 nitrogen, sp3 carbon. Even in that case also, nitrogen is more electronegative. Like this, you take any combination, by all the means, nitrogen is more electronegative than carbon. But guys, one important exception is there. So it is red alert. What is that exception? sp carbon is more electronegative than sp3 nitrogen. This is the case where carbon is more electronegative than nitrogen. Which carbon? sp carbon is more electronegative than nitrogen. You may ask me, sir, why you are discussing about electronegativity in inductive effect? As I mentioned already, inductive effect arises due to the difference in electronegativity only. So there is a need to discuss about the electronegativity. Now let us come back to the inductive effect groups. Now guys, see clearly, inductive effect two types are there. What are the two? Plus I groups and minus I groups. Plus I means electron donating groups, whereas minus I means electron withdrawing groups. For example, let us think one atom is there. If it want to donate electrons, first of all it should be electron rich, and you know well that electron rich will have negative charge. So plus I groups have overall negative charge, whereas minus I groups have overall positive charge, or else the directly bonded atom should be more electronegative. Guys, here let us take some examples. Now you see here O minus, COO minus, R. May I know what do you mean by R? R means what? Alkyl group. So in this way, these are all plus I groups, electron donating groups. Now here examples for minus I groups, then carbonyl groups. What is carbonyl, guys? C double bonded O. Now tell me, in carbon and oxygen, which is more electronegative? Yes, it is oxygen. What happened then? Pi bond will shift towards oxygen, then carbon will get positive charge. Since it is electron deficient, so it will withdraw electrons from someone. Then here you see carboxyl group is there, and you know carboxyl group is C double bonded OH. Now you see carbon is bonded to more electronegative oxygens. Therefore, electrons will move towards oxygen. Again, carbon will become deficient, so it will withdraw electrons from someone. Therefore, in this way, you see carbonyl groups, next carboxyl groups, next esters, halogens, cyanide. These are all minus I groups because they withdraw electrons from someone. Now, in case of isotopes, guys, I think you know isotope means what? Same atomic number should be there and mass number should be different. So in case of isotopes, plus I effect depends on mass number of the isotope. Now, for example, you see clearly here, tritium mass number is 3, deuterium mass number is 2, hydrogen mass number is 1. So which is having more plus I effect? Yes, it is tritium, than deuterium, than protium. Guys, look into alkyl groups now. In case of alkyl groups, plus I effect directly proportional to number of carbon atoms. Now here you see now, for example, methyl, ethyl, propyl, butyl, you see top to bottom number of carbons are increasing, you see. Therefore, plus I effect also increases. I hope it is clear now everyone. And the two important points of inductive effect are plus I power of anion greater than neutral. How? For example, let me take anion. Let me take neutral. Tell me who is more electron rich? Yes, electron rich is this one. Therefore, plus I power of anion is greater than neutral. Now, similarly, minus I power of cation is greater than neutral. How? Now, for example, let us take one cation here and let us take one neutral here. Who will withdraw electrons easily? Tell me. Yes, it is cation. Therefore, cation is having more minus I power than neutral. So, these are some important points about the inductive effect. Guys, let us do some questions about the inductive effect. So, what is the question here you see now? Compare the minus I powers of the following. Guys, what is minus I power? Minus I, as I already stated, it is electron withdrawing power. Minus I means what? Electron withdrawing group. So first question is what here? See clearly. Fluorine, chlorine, bromine, iodine. So minus I power is more for fluorine than chlorine, than bromine, than iodine. Why? The reason is that fluorine is more electronegative, so it can withdraw electrons easily than chlorine, bromine and iodine. Then second question you see clearly, fluorine, OH and NH2. So what is their minus I power order? Minus I power order is this one you see no, fluorine greater than OH greater than NH2. Why? As I stated already that fluorine is highly electronegative, second highest is oxygen and third highest is nitrogen. So in this way, fluorine greater than OH greater than NH2 is the answer for second question. Well done guys. Now coming to the point of third one, NH3 positive, NF3 positive. Now if you see the structure of NH3 positive here, so this is the NH3 positive, whereas this is the NF3 positive. This is the NF3 positive. Now, so here you see, now tell me, in hydrogen and nitrogen, which is more electronegative? Yes, it is nitrogen. So all these bond pairs will move towards nitrogen. As a result, the positive charge will decrease here. Whereas in second case, who is more electronegative? Fluorine. So all the bond pair of electrons will move towards fluorine here. Therefore here positive charge increases. That means cationic nature is more. And just now I mentioned that cationic nature is more means withdrawing tendency. That means minus I power is more. Therefore, if we take NH3 plus and NF3 plus, so which is having more minus I power, tell me? Answer is obviously NF3 plus. Then next question, NO2 and fluorine, which is having more minus I power? Guys, this is one important question where many students will confuse here. So tell me, in NO2, nitrogen is bonded to more electronegative oxygens. Then what happen? The electrons will move towards oxygen. Then some sort of positive charge is there on nitrogen. But on fluorine, such type of positive charge is not there. It is neutral. Therefore, minus I power of cation greater than neutral. Therefore, NO2 is having more minus I power than fluorine. Now, the most interesting question is minus I power of OH and OR. So, here that I want to explain. OH is this one, OR is this one. R means what guys? Nothing but one carbon. So can you tell me where electronegativity difference is more? Electronegative difference is more here than here. So electronegative difference is more means this oxygen is having more negative charge. This oxygen is having less negative charge. When negative charge is more, donating tendency is more. That means plus I power is more and minus I power is less. Whereas in OC, what happened? Donating power is less here and withdrawing power is more here. Therefore, which is having more minus I power, guys? It is OR. OR is having more minus I power as I mentioned here. So, these are some interesting questions about the inductive effect. Now, guys, let us see some applications of inductive effect. In that, first one you see, no, stability of carbocation. Remember, guys, carbocation is stabilized by plus I groups and destabilized by minus I groups. Now, let us take one example here. Now, you see, in primary carbocation, only one alkyl group is there. That means only one plus I group is there. Whereas in secondary, two alkyl groups are there which will stabilize the carbocation. In tertiary, three alkyl groups are there, you see, which stabilize the carbocation more easily. Whereas in methyl carbocation, there is no plus I group which will stabilize the carbocation. So guys, may I know out of these which is more stable carbocation? Yes, it is tertiary carbocation than secondary carbocation than primary carbocation. So this is the stability order of the carbocations. I hope it is clear to everyone. Guys, let us do some questions on stability of carbocations. Now you see here three questions are given to you, three compounds are given to you. Arrange them in stability order. So now if you see clearly, first one is primary and this is tertiary and this is secondary. So as per our order, tertiary is more stable. So tertiary is second one, then after third one, then after first one. I hope you understood. Then coming to the point of second question, guys. Now in second question you see this is the primary carbocation, this is the tertiary carbocation, this is the secondary carbocation. So as I mentioned already that tertiary is more stable. So what is our answer then? Second one is more stable than third one than first one. Now let us move to the third question. Here four compounds are given and they are asking arrange them in the stability of carbocation order. So now you see here oxygen is there. I think you know it is a minus I group. Minus I group will destabilize the carbocation. Similarly, here also minus I group is there which will destabilize the carbocation. And here nitrogen is there which also destabilizes the carbocation because minus I. And here two nitrogens are there you see. So they are also minus I groups which will destabilize the carbocation. But you know inductive effect is distance dependent. That means it is inversely proportional to distance. So where distance is more means in 1 and 3 distance is more from minus I group to positive charge. Now out of 1 and 3 how to check now? In 1 you see oxygen is exhibiting minus I, whereas in 3 nitrogen is exhibiting minus I. May I know which is more electronegative? So here I am writing you see electronegativity of oxygen is more than nitrogen. Therefore oxygen is having more minus I power. Therefore it destabilizes the carbocation to large extent. Then can you tell me now out of the three which is more stable carbocation means third one. After third one now first one will come. Then coming to the point of now second and fourth. In second one only one minus I group is there, whereas in fourth one two minus I groups are there. So guys out of the two second and fourth which is more stable comparatively? Second is more stable than fourth. I hope it is clear, everyone. So this is the stability order of these carbocations. Now let us move to the stability of carbene ions. Guys, what is carbene ion? Carbene ion means negatively charged carbon. Now here you see now stability of carbene ion directly proportional to minus I, inversely proportional to plus I. Now coming to the point of example, you see here one alkyl group is there which will show plus I, and here secondary carbene ion, two alkyl groups are there, whereas tertiary carbene ion, three alkyl groups are there, and you know alkyl groups will show plus I effect. They will decrease the stability of carbene ion, but in first one no one is there to decrease the stability. Am I right? Therefore, what is the stability order of carbene ion, guys? It is primary greater than secondary greater than tertiary. This is the stability order of the carbene ions. Now, guys, let us take some questions now. Arrange the following in the stability order of carbene ions. So, now you see first question here. Now, so see clearly, tell me now, here minus I group is there, you see oxygen, here also and here also. As I told just now, minus I groups will stabilize the carbene ion. At the same time, inductive is distance dependent. So in first one, minus I group is very near to the carbene ion, whereas in second one you see distance increased. In third one, distance still increased. So guys, can you tell me what is the stability order? Yes, it is 1 greater than 2 greater than 3. I hope it is clear to everyone. Now, coming to the point of second question, guys. So now tell me everyone now, stability order. So you know this first one is there na, it is sp hybridized carbon. Second one is there na, it is sp2 hybridized. Similarly, third one sp2 hybridized. Whereas last one sp3 hybridized. So electronegativity directly proportional to percentage of S character. S character is more for sp. Electronegativity is more for sp. Negative charge is more stable on more electronegative atom. Once again, negative charge is more stable on more electronegative atom. Therefore, out of these four, first of all A. Now B and C are in competition. Now you see in B, phenyl ring is there, which will exhibit minus I effect. Whereas in C, alkyl groups are there, you see, which will exhibit plus I effect. Therefore, out of B and C, which is more stable, guys? It is B. Very good. Then C will come and finally D will come. So this is the answer for this question. I hope it is clear to everyone. So once again I am telling you, negative charge is more stable on more electronegative atom. More electronegative is what? sp hybridized carbon. Now let us move to the next and last application, that is stability of free radical. Guys, what is free radical? Free radical is this one, carbon with one electron. Now who will stabilize the radical? So see clearly, stability of radical directly proportional to plus I and inversely proportional to minus I. So now let us take one example here, you see now. Now in first one you see three alkyl groups are there, so it is a tertiary radical. Whereas in second one, two alkyl groups are there, so it is a secondary radical. And here only one alkyl group is there, primary radical. And in the last one there are no alkyl groups, it is a methyl radical. Guys, can you tell me now, as per this principle, the stability order of the radicals? Yes, it is tertiary greater than secondary greater than primary. So at the end, I want to summarize the stabilities of carbocations, carbene ions and free radicals. So see clearly, guys, carbocation stability tertiary greater than secondary greater than primary, whereas stability of carb anion is reverse. primary greater than secondary greater than tertiary. Next, stability of carbon free radical, it is a tertiary greater than secondary greater than primary. So this is the stability order of carbocations, carbanions and free radical. I hope this video is interesting. Thank you for watching my video. Thanks one and all.